Today on Roadzone Reviews, lithium batteries are basically in everything we use. Today our phones, laptops, and just about every piece of tech in our homes. But what's even more impressive is that over 95% of all electric vehicles globally run on lithium-ion batteries. That's right, lithium is still king in the battery world, and most alternatives haven't come close to dethroning it. But here's the kicker. Lithium-ion batteries haven't had a major breakthrough in quite some time. Energy density has barely improved, while prices and fire risks remain a serious concern. That's one big reason EV adoption hasn't hit mass scale yet. They're still pricey, and many consumers don't feel completely safe. Even Tesla, the leader in battery innovation, has hit a wall. Elon Musk himself admitted that skyrocketing raw material prices have hit hard. The price of lithium and other essential materials has surged, battery cell prices doubled, and lithium alone shot up by as much as 500%. So, it's clear Elon Musk is now looking beyond lithium. Now, there's buzz from Tesla's most secretive lab that a brand new battery is in the works, something that could totally upend the lithium empire. A revolutionary battery design that ditches rare materials and delivers 3 times the energy density. Of course, like any early tech, it's not without challenges, but across nearly every metric, it crushes lithium. And when its final drawbacks are ironed out, this battery won't just compete with lithium, it could wipe it out entirely. So, what exactly is this breakthrough battery? Why is Elon Musk so interested? And what makes it such a potential game changer? We dug deep into this new technology, and today, we're revealing everything. Tesla's rise was powered by lithium using LFP and NMC batteries in the Model 3 and Model Y. And the new 4680 battery in the Cybertruck. All of these rely heavily on lithium, nickel, and cobalt, some of the most expensive elements in battery manufacturing. Elon Musk has acknowledged that the 4680 battery, despite being a major step forward, actually costs more to produce due to its complex materials mix. Yes, the 4680 battery is among the best Tesla has ever made, but ironically, it's only found in the $69,990 Cybertruck, a premium battery stuck in a premium vehicle, disappointing for everyday buyers. Many now wonder whether this tech will ever reach mainstream models like the Model 3 or Model Y, but with lithium prices rising steadily, scaling this battery to lower-cost EVs seems highly unlikely. Tesla is still deeply reliant on lithium chemistry, and that's a major hurdle in launching a truly affordable electric car. Musk has teased a $25,000 Tesla for years, but the goal keeps getting pushed back. That's why recent leaks from Tesla's R&D division have caught so much attention. Word is they're working on an entirely different battery chemistry, aluminum-ion, or what's being referred to as the A1 battery. It's a first-gen battery tech that could blow lithium-ion out of the water. Instead of lithium, aluminum-ion batteries use aluminum ions to store and transfer charge. These batteries contain 3 major components: the anode, made from metallic aluminum; the cathode, built from materials like graphene, graphite, or metal oxides; and the electrolyte, which facilitates the flow of aluminum ions. Now, here's why this is important. Each aluminum ion carries 3 positive charges compared to just 1 in lithium. That means aluminum ions deliver 3 times more energy per ion with better energy density, without rare earth materials or overly complex engineering. This design is a leap forward. Aluminum-ion batteries could store far more energy than traditional lithium batteries of the same size. Reports suggest Tesla's aluminum-ion prototypes have achieved over 700 Wh/kg in live testing, way beyond the typical 180 to 200 watt-hours per kilogram we see in current EV. For context, the Model 3 long-range AWD with a 79 kWh lithium battery gets 346 miles of range. If you swapped in a battery with triple the density, the range could jump to over 1,000 miles. Realistically, pack-level limitations and thermal systems means 767 miles is a more achievable target, but that's still double today's range. Unlike lithium-ion tech, which has remained largely stagnant at around 250 watt-hours per kilogram for decades, aluminum-ion offers exponential gains. Even Tesla's 4680 battery only tops out at around 272 Wh/kg beyond density. There's another driver: cost. Musk has been vocal about the insane costs of lithium battery materials, pointing to lithium's constrained supply and rising demand. Tesla is facing a resource bottleneck, and lithium just isn't abundant enough, but aluminum, it's everywhere. The most plentiful metal in Earth's crust, at 0.13% of its weight. Its main, or bauxite, is spread across dozens of countries, and we've got 1.59 billion tons in reserve. Unlike lithium, aluminum is easy to source, inexpensive, and geopolitically stable. This gives aluminum-ion batteries a cost advantage that's hard to ignore. Based on what we've seen, aluminum-ion batteries could cost just $40 to $65 per kilowatt-hour at scale, compared to lithium batteries, which run between $80 and $145 per kWh. That's without even factoring in nickel or cobalt. In practical terms, if a Tesla Model Y's battery costs around $11,000 today, switching to aluminum-ion tech could slash that to $4,300, $5,300. That change alone would dramatically lower production costs. Meanwhile, lithium's price roller coaster continues, sometimes dropping, but mostly climbing steeply. In 2024, lithium carbonate averaged $8,200 per ton. By early 2025, it hit over $9,200. Compare that to aluminum's stability and abundance, and you'll see why this transition makes so much sense. But wait, there's more. Aluminum-ion batteries charge faster, much faster. Lithium batteries take 25 to 35 minutes to hit 80%. Aluminum-ion cells can charge fully in just 15 minutes. That's not marketing hype, it's because aluminum ions move through electrolytes 3 times faster than lithium ions. This also means better heat management and reduced thermal degradation. Aluminum-ion batteries also blow past lithium in longevity. While lithium batteries typically last about 2,000 charge cycles or 3 to 5 years, some studies show aluminum-ion cells lasting up to 15,000 cycles. That's potentially 30 years of use. Why? Because aluminum is stable, it doesn't react violently with air or water. It even forms a protective oxide layer, resisting corrosion and boosting lifespan. Plus, aluminum-ion batteries don't suffer from dendrite formation, one of lithium's biggest weaknesses. Dendrites are metal spikes that grow inside lithium batteries during charging, causing short circuits and even fires. But aluminum-ion cells charge evenly and avoid this issue altogether. Research from Stanford and other top labs confirms that these batteries can handle tens of thousands of cycles with little degradation. Speaking of fires, aluminum-ion batteries are far safer. Lithium cells can explode if punctured, overcharged, or overheated. The smoke is toxic, and fires are extremely hard to extinguish. Aluminum-ion batteries, thanks to their stability, don't face those risks, making them the safer and smarter long-term option. On top of that, aluminum-ion batteries are far more recyclable. Up to 80% of aluminum fluoride salts used in these batteries can be reclaimed, and that figure could rise even higher with industrial-scale processes. Solid aluminum foil used in the anodes can also be reused after cleaning. So environmentally, this battery is way ahead. Still, it's not perfect. One of the biggest challenges right now is performance in cold climates. Low temperature efficiency is a hurdle researchers are working hard to overcome. Without solving this, mass adoption in colder regions would remain limited, but the potential is undeniable. If Tesla can crack the code and fix this temperature issue, aluminum-ion could revolutionize EVs. Word is Tesla is already preparing for mass production at a facility near Giga, Nevada, with the new aluminum-ion battery line expected to go live by the end of the year. The new A1 battery, once in production, could find its way into mainstream models like the Model 3 and Model Y, delivering high-range, ultra-fast charging and long life at a fraction of today's costs. It could be the key to unlocking the $25,000 Tesla that's been years in the making. Aluminum-ion batteries could change everything, not just for Tesla, but for the entire EV industry. They offer speed, safety, longevity, affordability, and environmental sustainability. The only question left is, how soon will they be ready? What do you think? Are you excited about this shift away from lithium? Let us know your thoughts in the comments. If you found this video insightful, smash that like button, subscribe to Road Zone Reviews, and hit the bell so you never miss the future of EVs. Thanks for watching, and as always, stay driven. See you in the next one.